Okay, let's smash out a couple more questions before lunch. Right, f of x is 8 plus 27x cubed, sorry, to the power of a third. And we need to do a binomial expansion on this. Now, one of the first things that occurs to me in a question like this is it's not the 27x cubed which is problematic here. It's actually the 8. Yeah, and that's always struck me as strange, but or it's slightly counterintuitive anyway. But in the binomial expansion, it's the 1 plus whatever. Let me put it like this: it's a 1 plus x to the n. Yeah, the x can be pretty much whatever you like. It can be replaced with 27x cubed, for example. But it must start with a 1 for you to be able to use the 1 plus n, but 1 plus xm and x, if you like, plus n times n minus 1. Sorry, I'm going off the screen here. X squared over 2 factorial, etc., etc. I wonder, maybe I should just write that out. In fact, let's start again and write the binomial expansion out for 1 plus x to the n, because it is handy for these kind of questions to just see it in front of you. So 1 plus nx plus n times n minus 1 x squared over 2 factorial plus n times n minus 1 times n minus 2 x cubed over 3 factorial, etc. That's what we're going to do. But before we start, we absolutely must deal with that 8. That 8 is a problem. Okay, so how are we going to deal with that? Well, we're looking at the cube root of 8 plus 27x cubed. It might be wise, maybe you prefer to look at it in brackets, but let's take the 8 out first and make it 1 plus 27 over 8 x cubed, and then both of these things have to be put to the power of a third. Do not rush this first step. I've seen loads of times where students just think that this first dividing by the 8 is easy. It's not, because you have to remember to put it to the power of a third. And 8 to the power of a third, well, cube root of 8, that is 2. So we're actually going to be doing 2 times 1 plus 27 over 8 x cubed to the power of a third. And so a third, not half. And so consider first just 1 plus 27 x cubed over 8 to the power of a third. Let's do that binomial expansion and then try not to forget to times it by 2 at the end. I've often, to be honest, when I do these consider things, I often forget to times it by 2 at the end. Okay, so what do we got here? We've got 1 plus 27x cubed over 8 times by a third, because this is my x, yeah? That is my x over there. It's being replaced with x. So I'm going to do 1 plus a third, because that's my n, times by 27x cubed over 8. I'm now going to check and see how far I'm going to go. The first 3 non-zero terms, so just one more term is all I need. Now it's going to be a third. It always winds me up when somebody wants to write a third minus 1 here. If you're one of those people, change your ways. Please do a third take away 1 in your head. Multiplied by, now we've got to do 27x cubed over 8. And we've got to square that, yeah? It's going to be ugly. You might want to get your calculator out for this one. And then don't forget, we've got to divide that by 2 factorial. Okay, let's see if I can get this right without a calculator. Apologies if I get this wrong. I will check it at the end. I think the 27 over 3 cancels to 9. So I think that first term is going to be 9x cubed over 8. And I think the second term is going to be, well, firstly, it's going to be a negative. So let's just scribble that out and make that a minus. I can see that from the third times minus 2/3. Now, when you've got the 2/3 and you divide it by 2, that's just going to make a third. So it's going to be 1 over 9, and let's not rush it too quickly. 1 over 9 times by, okay, 27 over 8 squared. What is that going to be? That's going to be 3 cubed squared, which is 3 to the power of 6. And 3 to the power of 6 is like 9 cubed. So that's going to be 729 over x to the 6 over 8 squared, which is 64. Now, 729 divided by 9 is going to be 9 squared. I think it's going to be 81, isn't it? So we get 1 plus 9x cubed over 8 minus 81x to the 6 over 64. But at the very, 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 very end, we need to times that all by 2. Hence, we need to double this, and 8 plus 27 x cubed to the power of a third equals, right, let's double all of this, 2 plus 9x cubed over 4 minus 81x to the 6 over 32. Yeah, because if I'm double everything, I could just halve the denominators. Okay, hope that one makes sense. Let's go to the next one now. Let's shift and let's cancel all of that. I hope that's clear. And let's go to the next question. Oh yeah, I need to do this. There we go. Okay, what we got next? We've got a little bit of a separation of variables, it looks like to me. So let's have a go. Okay, first part is just partial fractions though. And partial fractions, especially with what I refer to as a type 1 partial fraction or a basic partial fraction, we can do this with cover-up rule. Let's give it a little go. Okay, we know it's going to be of the form a over 2x minus 1 plus b over x plus 1. So let's cover up, like try and cover that up, that 2x minus 1. Put a little thumb on the screen if you like, the 2x minus 1. But also plug in what makes it 0, which is x is a half. That's going to give you 5 take away 2, which is 3 on the top, divided by a half plus 1, which is 1.5 on the bottom, which gives you a as 2. Because 3 divided by 1.5 is 2. Now let's try and do the same for b. We're going to plug in minus 1 on both top and bottom. Plugging in minus 1 gives you 9 on the top. On the bottom here, you're going to get minus 3. So you've got 9 divided by minus 3, which is, of course, minus 3. So we're going to have minus 3 there on x plus 1. And technically, really, it doesn't look very nice to write it like that. Really, you should write 2 over 2x minus 1 minus 3 over x plus 1. And that's a nice little simplified answer. Okay, for part B, let's scroll down a little bit again. Let's see if I can do that. Oh no, that moves the text. I'm going to have to clear that now. So I hope you remember 2 over 2x minus 1 minus 3 over x plus 1. Let's now see how that helps us with part B. Okay, so we've got a differential equation here, and differential equations are always tricky. And I don't think they ever get massively easy in maths. But really, the trick here is to separate the variables. That's the only method you've got really at A2 single maths for solving a differential equation. Actually, in further maths, we will develop loads of approaches to solving first order and second order differential equations, but that's all to come in the post. But anyway, the trick is put everything to do with dy on the side with dy. So I'm going to have 1 over y dy if I move this y over to that side, and then move everything to do with x onto the right hand side. So 5 minus 4x over 2x minus 1 x plus 1 dx, and then to integrate both sides. That's what we're going to do. That gives me on the left hand side natural log of y equals, now on the right hand side we're going to have to write that as 2 over 2x minus 1, this is why we did the partial fractions, minus 3 over x plus 1 with respect to x. Now this is going to give us lots of natural logs because, as you can see, bottom differentiates to the top for that one, so that's just natural log of 2x minus 1, and this is where putting it in a modulus can be really important sometimes. Minus, imagine that 3 coming out of the integral, and it'll be just 1 over x plus 1, and so bottom would differentiate to the top, minus 3 ln x plus 1. But with these questions, never forget your plus c, yeah? Now, actually, it's probably going to be easier to write plus ln c here, or plus ln k. That's a lovely little trick that you learn for these separation of variables questions. If every other term has a natural log in it, why not make this term have a natural log in it? Yeah? Plus ln k. It's just a lovely little trick. Now, we need to find a natural log. Well, we need to find a constant of integration, yeah? And we're going to find it by plugging in what's called our boundary conditions, yeah? Oh, by the way, that is the general solution. The particular solution, so I've done part 1 really there. The particular solution is where you find the value of the plus c or plus k. So I've done part 1. Let's go on to part 2. We're going to plug in y is 4. So that's going to give me ln 4. On the right hand side, you're going to get ln 5. Oh, no, sorry, ln 3. Sorry, 2 times 2 minus 1 is too much for me today, obviously. Minus 3 ln 3 plus a ln k. Ln 3 minus 3 ln 3 is minus 2 ln 3. So you get ln 4 equals minus 2 ln 3 plus ln k. Personally, I'm going to shove that 2 ln 3 over, and I'm going to make it ln 4 plus, and let's make it ln 9 equals ln k. And then you can see, I hope, that k is 36, because ln 4 plus ln 9 is ln 36. So we get ln 36 is ln k. And hence, ln y equals, now let's put those two lns together, because we can certainly write them together. And let's also put the 3 up there as a cubed. So it's going to be 2x minus 1 over x plus 1 cubed. And then we're going to be adding ln 36, and we can tidy that up even more. I'm just desperate to keep this in view of the screen. Do you mind if I work up here? I know it's terrible going up the page with my writing here, but all right, I'll get rid of it. I'll remember it all and get rid of it. Okay, so this is the same as, you can obviously times the 36 into the other natural logarithm. So we're going to end up with ln y, if I've remembered this right, equals ln of 36 times 2y minus 1, or was it 2x minus 1, over x plus 1 cubed, all together, yeah? And now we can exponentiate both sides. That's a technical term. Use it when you want to sound clever. We're exponentiating both sides. Y equals 36 times 2x minus 1 over x plus 1 cubed. And the question is finished. Hope that made sense. Let me know if it didn't, and yeah, we'll see if we can fix it.